Hi everyone, you are watching Easy Math. Today's session is about polynomials. Polynomials appear in many areas of mathematics and science. For example, they are used to form polynomial equations, polynomial functions. They are also used in calculus, numerical analysis, and etc. To understand polynomial better, let's look at some important concepts like constants, variable, algebraic expression, etc. The first concept is constant. A constant is a fixed number that doesn't change. It is a fixed numerical value. Some examples of constants are 2, 5, 100, etc. The next concept is variables. A variable is a different quantity that takes different values in different conditions. It is denoted by small letter a, x, m, z, t, etc. in English alphabet. Our next concept is algebraic expression. It is a very important concept. It is a combination of constant, variables, and algebraic operations like addition, subtraction, multiplication, division, etc. Let's look at some example of algebraic expression. The first example is 4x. 4 is a constant and x is a variable. 4 and x are multiplied here. It is an example of algebraic expression. The next one is x plus 9. X is a variable and 9 is a constant. It is also an example of algebraic expression. The next one, x plus y by 6. Here x and y, these two are variables. And 2x square minus 3x plus 2. These four are some examples of algebraic expression. Our new concept is term. Parts of an algebraic expression connected by positive or negative signs are called terms. Let's see some examples. 9x. Here 9 is a constant and x is a variable. 9 and x are multiplied here. In this expression, one term exists. So in the expression 9x, only one term has, that is 9x. The next example is 3x plus 2y. In this algebraic expression, two terms are there, 3x and 2y. The next concept is coefficient. A coefficient is a multiplicative factor in some terms of the expressions. It is usually a number but may be an expression. Let's find some coefficient. For that, let's look at these algebraic expression. X to the power 4 plus 3x cube plus 4y square plus 5xy plus 2. Here the coefficient of x to the power 4. In the first term x to the power 4, we can write x to the power 4 as 1 into x to the power 4. 1 is the multiplicative factor of x to the power 4. Therefore, the coefficient of x to the power 4 is 1. Now, let's find the coefficient of y square. In the third term 4y square, we can write 4y square as 4 into y square. 4 is a multiplicative factor of 4y square. The coefficient of y square therefore is 4. Let's find the coefficient of 5x. In the fourth term 5xy, we can write 5xy as 5x into y. Therefore, the coefficient of 5x is y. Now let's discuss the most important concept, polynomial. As you can see, the word polynomial has been colored into two parts. poly and nomial. Poly means many and nomial means terms. That is, polynomial means many terms, and that's how the word polynomial comes about. Polynomial is an algebraic expression with non-negative integer exponents of variables. That means if in an algebraic expression the power of variable is always non-negative integer, then it is called polynomial. Let's look at some example. X plus 3. In this algebraic expression, x is the variable, and in the first term x, the power of x is 1, which is a whole number. Therefore, x plus 3 is an example of polynomial. The next one is 9a plus b plus 10. Here a and b are two variables. In the first term 9a, the power of a is 1. In the second term b, the power of b is also 1. Therefore, the variables a and b has non-negative integer exponents. Therefore, 9a plus b plus 10 is an example of polynomial. The next example, x square plus 3x plus 8. Here x is the variable. In the first term x square, the power of x is 2. In the second term the power of x is 1. Therefore, the power of x is non-negative integer. Therefore, x square plus 3x plus 8 is an example of polynomial. Now let's do some brainstorming to understand polynomial better. Which of the following expressions are polynomial? The first one is x cube minus x square plus 2. Now let's check whether it is a polynomial or not. In the first term x cube, the power of x is 3, and in the second term x square, the power of x is 2. Therefore, the power of x in this algebraic expression is always a non-negative integer. Therefore, yes, it is an example of polynomial. Next, x plus 1 by x. X is the variable. We can write x plus 1 by x as x plus x to the power minus 1. In the first term, the power of x is 1, but in the second term, the power of x is minus 1, which is not a whole number. Therefore, it is not an example of polynomial. The third example, root over x plus 7. We can write root x plus 7 as x to the power half plus 7. The power of x in the first term is half, which is a fraction. Therefore, root over x plus 7 is not an example of polynomial. The next one, 5t minus root 7. In the first term, the power of t is 1. So, 5t minus root 7 is an example of polynomial. The fifth example, cube root of z plus z. We can write this as z to the power 1/3 plus z. In the first term, power of z is 1/3, and in the second term, power of z is 1. But 1/3 is not a whole number. Therefore, this is not an example of polynomial. The sixth example, 3 root t plus t root 2. And the seventh example, root over 2x plus 1. Can you tell me whether these two are example of polynomial or not? Please let me know in the comment section. If the variable of a polynomial is x, we may denote the polynomial by px. Therefore, px equal to x square plus 7x plus 9. In this expression, x is the variable. So we can write px equal to x square plus 7x plus 9. Similarly, if the variable of a polynomial is y, we may denote the polynomial by py. Here we write py equal to y plus 7. Y is the variable here. Similarly, if the variable of a polynomial is z, we may denote the polynomial by pz or qz or rz. Here we write pz equals to zq plus zx square plus z plus 10. Now, the degree of polynomial. What is the degree of a polynomial? The highest power of the variable in the polynomial is called the degree of a polynomial. Let's find the degree of a polynomial. For that, let's write an example of polynomial px equal to 7x to the power 7 minus 4x to the power 6 plus 3x to the power 5 plus 10. Here in the first term, the power of x is 7. In the second term, power of x is 6. And in the third term, power of x is 5. Therefore, the highest power of the variable x is 7. Therefore, the degree of the polynomial px is 7. The next one, py equals to y cube plus 3y square plus 7. In the first term, the power of y is 3. In the second term, the power of y is 2. Therefore, the highest power of the variable y is 3. Therefore, the degree of the polynomial py is 3. The next one, px equal to 7x plus 10. Here, the power of x in the first term is 1. Therefore, the degree of the polynomial px is 1. So far, you have seen polynomials of one term, two term, polynomials of different degrees, etc. So let's classify the polynomials. The first type of polynomial is constant polynomial. By seeing the term, you can understand there is a polynomial where a constant exists. A constant polynomial consists only a constant term. It can be denoted as px equals to constant. For example, 2, 10, minus 5, etc. We can write 2 as 2 into x to the power 0 since x to the power 0 equals to 1. Therefore, the degree of the polynomial is 2, 0 since the variable x has power 1. Sorry, the degree of polynomial 2 is 0 since the variable x has power 0. Next, minus 5. We can write minus 5 as minus 5 into y to the power 0 since y to the power 0 equals to 1. Therefore, the degree of the polynomial minus 5 is 0. The next type is zero polynomial. By seeing the term, you can understand there is a polynomial where 0 exists. The constant polynomial 0 is called the zero polynomial. The degree of zero polynomial is not defined. We will discuss the degree of zero polynomial later. The next type is monomial. A polynomial of one term is called monomial. Let's see some examples. 2. In this polynomial, only one term exists. Therefore, this polynomial is called monomial. The next example is 3x. In this polynomial, one term exists, that is 3x. So it is an also example of monomial. The next one, 3ab. This is also an example of monomial. The next type is binomial. A polynomial of two terms is called binomial. Let's see some example of binomial. X plus 10. In this example of polynomial, we can see two terms exist, x and 10. Therefore, yes, it is an example of binomial. The next, a plus b. A and b, these two are variables. In this polynomial, two terms are there, a and b. Therefore, it is also an example of binomial. The next, 3ab plus 7. Here 3ab and 7, these two are two terms of this polynomial, so it is an example of binomial. The next type of polynomial is trinomial. A polynomial of three terms is called trinomial. The examples, 3a plus b plus c. Here we can see 3a, b and c. Three terms are there. So it is an example of trinomial. 2x square minus 3x plus 2. Here also three terms exist. Therefore it is an example of trinomial. The next, 3x plus y plus 9. There are also three terms. Therefore this is an example of trinomial. So mono means 1, bi means 2 and tri means 3. The next type of polynomial is linear polynomial. A polynomial of degree 1 is called linear polynomial. That means if the degree of any polynomial is 1, it is called linear polynomial. Let's see the examples. Px equal to 3x plus 2. In this polynomial, x is the variable. In the first term 3x, the power of x is 1. Therefore, the degree of the polynomial px is 1. So it is an example of linear polynomial. The next, qy equals to 7y. In this polynomial, y is the variable and the degree of this polynomial is 1 since the power of y is 1. Therefore, degree of px equals to degree of qy equals to 1. A linear polynomial is of the form ax plus b, where a and b are constants and a not equals to 0. A linear polynomial has at most two terms. In the first example, px equals to 3x plus 2, here a equal to 3 and b equals to 2. And in the second example, qy equals to 7y, here a equal to 7 and b equals to 0. Let's move on to the next type of polynomial, that is quadratic polynomial. A polynomial of degree 2 is called quadratic polynomial. That means if the degree of any polynomial is 2, it is called quadratic polynomial. Let's see some example. The polynomial px equals to 7x square plus 3x plus 2. Here in the first term the power of x is 2, in the second term the power of x is 1. Therefore the highest power of x is 2, therefore the degree of px is 2. The next, qx equals to x square plus 1. The degree of qx is 2 since the highest power of x is 2. Therefore, the degree of px equal to degree of qx equals to 2. A quadratic polynomial is of the form ax square plus bx plus c, where a, b, c are constants and a not equals to 0. A quadratic polynomial has at most three terms. In the first example, 7x square plus 3x plus 2, here a equals to 7, b equals to 3 and c equals to 2. And in the second example, qx equals to x square plus 1. Here a equals to 1, b equal to 0 and c equal to 1. The next type of polynomial, cubic polynomial. A polynomial of degree 3 is called cubic polynomial. That means if the degree of any polynomial is 3, it is called cubic polynomial. Let's see the examples. Px equals to x cube plus 3x square plus 7x plus 1. Here the degree of px is 3, since the highest power of x in this polynomial is 3. Next, qy equals to 3y cube. Therefore, the degree of the polynomial qy is 3, since the power of y, the highest power of y in this polynomial is 3. Therefore, px and qy, these two are the examples of cubic polynomial. Therefore, degree of px equal to degree of qy equals to 3. A cubic polynomial is of the form ax cube plus bx square plus cx plus d, where a, b, c, d are constants and a not equals to 0. A cubic polynomial has at most 4 terms. In the first example, x cube plus 3x square plus 7x plus 1, here a equals to 1, b equals to 2, 3, c equals to 7 and d equals to 1. And in the next example, 3y cube, here a equal to 3, b equal to 0, c equals to 0 and d equals to 0. Now that you have seen what a polynomial of degree 1, degree 2 or degree 3 looks like, can you write down a polynomial in one variable of degree n for any natural number n? A polynomial in one variable x of the degree n is an expression of the form a n x to the power n plus a n minus 1 x to the power n minus 1 plus a n minus 2 x to the power n minus 2 in the same way plus a1x plus a0, where a0, a1, a2 in the same way an are constants and an not equals to 0. This is called the general form of polynomial. Now again let's discuss zero polynomial. In the expression 1, if in any particular case we put a0 equals to a1 equals to a2 equals to all the constant zeros, that means if we put 0 in place of all the constant, we will get the zero polynomial. So the degree of the zero polynomial is not defined. Today we have discussed the concept of constant, variable, algebraic expression, term, coefficient, polynomial, degree of the polynomial, types of the polynomial. If you have any doubt, then you can let me know in the comment section. Next day we will discuss remainder theorem, factorization of polynomial, etc.